Welcome to this video on the Automic Automation GCP Data Fusion Integration Solution. In this video, we will explain the GCP Data Fusion integration and what it brings to the Automic Automation user community. Google Cloud Data Fusion is a fully managed, cloud-native data integration service provided by Google Cloud Platform, GCP. It simplifies the process of building and managing ETL and ELT data pipelines for ingesting, preparing, and transforming data from various sources. This service offers organizations a visual interface for designing pipelines, scalability to manage large datasets, pre-built connectors for smooth integration, and capabilities for processing data in both batch and real time. It enables the efficient extraction of insights from data while leveraging Google Cloud's robust security and reliability. Integrating Automic Automation with GCP Data Fusion allows you to run pipeline jobs in your workspace from Automic Automation. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the configuration of the agent and the design of the two core object templates, connections, and jobs. Finally, we'll run through a demo. Automic Automation plays a central role in orchestrating operations across multiple environments, including the cloud. Automic Automation synchronizes these processes with other, non-cloud operations. By integrating GCP Data Fusion, we can configure process automation centrally in Automic Automation and then trigger, monitor, and supervise everything in one place. GCP Data Fusion processes can then be synchronized with all other environments routinely supported by Automic Automation. GCP Data Fusion's role is reduced to execute the jobs. All other functions, especially those pertaining to automation, are delegated to Automic Automation. This means that we don't have to log into the GCP Data Fusion environment and keep on refreshing it by ourselves. Automic Automation manages all the execution and monitoring aspects. The Automic Automation integration provides a simplified view to run pipeline jobs. Automic Automation lets us build configurations with intuitive interfaces like drag-and-drop workflows and supervise processes in simple dashboard tools designed natively for operations. Statuses are color-coded, and retrieving logs is done with a basic right-click. From an operations perspective, Automic Automation highly simplifies the configuration and orchestration of GCP Data Fusion jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workload. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workload. A conventional architecture involves two systems, the Automic Automation host and a dedicated system for the agent. The agent is configured with a simple INI file containing standard values: system, agent name, connection, and TLS. When we start the agent, it connects to the engine and it adds two new objects to the repository, a connection object to store the GCP Data Fusion endpoint and login data, and a job template designed to trigger run pipeline jobs. Let's assume we're automating for 4 instances of GCP Data Fusion. We create a connection object in Automic Automation for each instance by duplicating the con template for each of these instances. Lastly, we create the run pipeline jobs in Automic Automation for each corresponding process in GCP Data Fusion. The Automic Automation jobs include the connection object based on the target system. When we execute the jobs in Automic Automation, it triggers the corresponding process in GCP Data Fusion. We're able to retrieve the successive statuses in the cloud and finally generate a job report. In Automic Automation, this job can be incorporated in workflows and integrated with other, non-cloud processes. The procedure to deploy the GCP Data Fusion integration is as follows. First, we download the integration package from Marketplace. This package contains all the necessary elements: We unzip this package, which produces a directory containing the agent, the INI configuration files, and several other items, like the start command. We use the appropriate INI file for our specific platform. GCP Data Fusion is a standard Automic agent. It requires at least 4 values to be updated: agent name, Automic system, JCP connection and TLS port, and finally TLS certificate. When the agent is configured, we start it. New object templates are deployed. We create a connection to every GCP Data Fusion instance we need to support. For this, we use the template con object, which we duplicate as many times as we need. The con object references the GCP Data Fusion endpoint. Finally, we use the GCP Data Fusion template job to create the jobs we need. We match these Automic automation jobs to the GCP Data Fusion run pipeline jobs, reference the connection object, and run it. We're able to supervise the jobs, generate logs, and retrieve the statuses. The jobs can then be incorporated into non-cloud workflows. We install, configure, and start an agent to deploy the GCP Data Fusion integration. The agent is included in the GCP Data Fusion package, which we download from Marketplace. We unzip the package, which creates a file system agents/datafusion/bin that contains the agent files. Based on the platform, we rename the agent configuration file ucxjcidx and set a minimum of 4 values: the agent name, the AE system name, the host name and port connection to the automation engine's GCP, and finally the directory containing the TLS certificate. Finally, we start the agent by invoking the JR file via the Java command. The agent connects to the AE and deploys the object templates needed to support the integration, the con, or connection object, and the GCP Data Fusion run pipeline job. In our demo, we will create a connection object. Once we have established the connection to the GCP Data Fusion environment, we'll create a run pipeline job. Finally, we'll execute and supervise the job. Welcome to the Data Fusion environment. Click on the list to view all the pipelines. These are the pipelines we have already created. We will use one of these pipelines for our demo today. Let's move on to the Automic system. Here, we create a connection object with specific inputs to connect to GCP Data Fusion. We must enter the endpoint, which is the URL of the GCP Data Fusion environment. Next, we specify an authentication type from the drop-down menu. Currently, we support the service account key, which you can provide directly as JSON or via a file path. We select the file path input type and specify the location of the file that contains the authentication information for loading data into Data Fusion. If you are using a proxy in your environment, you can specify the proxy hostname, port, username, and password in the proxy section. Once the connection object is defined, you can create a run pipeline job. The connection drop-down list lets us select the appropriate connection object. Following the connection input, the job requires the namespace ID that contains the relevant pipeline. Then, you can select the pipeline name from a list of available options in the picker dialog. Also, optionally, in the pipeline parameter, we can either type a JSON or specify a file path stored on the agent machine. This allows you to pass arguments created at runtime to Data Fusion in JSON format. Everything is configured now, so we save and execute the job. Let's have a look at the reports. The agent plog is an additional report type that captures everything related to the job execution from the Automic automation perspective. It lists all the parameters used to run the job and contains the response received from the target system. In our case, we see that the execution was successful. The report captures the information that the target system sends to Automic automation when the job has been executed. The metrics logs, which we are fetching from the Data Fusion system and updating here. The agent logs capture the activities occurring in Data Fusion. and we are storing them here for reference. Let's switch to the executions view. The details pane shows the remote status field, which tracks the job status in the target environment. The execution was completed successfully. The details pane also shows an object variable called and df_response hash and df_unID hash. It helps us clearly identify the specific job execution, which we can use for further analyses. Now, let's take a quick look at the job status in the Data Fusion instance. As you can see, this was the job that we triggered, and it has completed successfully. That wraps up the demo on how Automic Automation can integrate with Google Cloud Data Fusion to execute and monitor various jobs. Thank you for watching this video.